Welcome back. Today we're getting into an explainer that is literally going to shatter everything you thought you knew about ancient tech and human intelligence. We're looking at the absolutely awe-inspiring astronomy of the ancient Maya.
To really wrap our heads around what we're dealing with here, just think about this number, 14. The ancient Maya actually tracked the orbit of the planet Venus to within an astonishing 14 minutes of accuracy. And the crazy part, this wasn't just some lucky guess by one guy over a single lifetime. This was a painstaking calculation that they maintained and refined over a massive 500-year span.
Which immediately begs the ultimate mystery, right? How on earth do you track a distant planet to within 14 minutes of accuracy without a telescope? How do you pull off that kind of staggering, mind-bending mathematical precision without a single piece of modern technology?
Okay, let's dive into this. To unpack this seemingly impossible achievement, we're going to look at their precision without telescopes, their deep obsession with the great star, the secrets hidden in the Dresden Codex, how they used buildings as fixed observatories, and finally, the massive cosmic stakes behind all this math.
So, Part 1, Precision without telescopes. Let's look at what they lacked and what they actually had.
I want you to consider the stark reality of their toolkit for a second. The Maya had absolutely zero glass. That means no lenses, no telescopes, nothing. They didn't even have metal tools to create precision instruments or mechanical clocks to time the movement of the night sky. Plus, they were totally isolated from the big astronomical traditions of the Greeks or the Babylonians or the Islamic world. But they countered all of that with something else: brilliant, multi-generational patience, a completely next-level mathematical system, and these vast architectural alignments. They relied 100% on human observation, meticulously recording it over centuries.
And this brilliantly illustrates just how well that worked. Take a look at the solar year. The Maya calculated it at 365.2420 days. Our modern, technologically verified value, 365.2422. Guys, that is a mind-blowing difference of just 17 seconds a year. 17 seconds. They're tracking a Venus's synodic period, which is just the time it takes the planet to return to the exact same spot in our sky, was off by only 14 minutes per cycle. Even their lunar month calculation missed the mark by a mere 34 seconds. Honestly, this is a level of accuracy that's almost hard to comprehend for a civilization relying entirely on the naked eye.
Moving on to Part 2, Obsession with the Great Star and the Intense Danger of No Ek.
So the Maya called Venus No Ek, which translates to the great star. But they weren't just casually stargazing out of, scientific curiosity. To the Maya, Venus was a celestial body of immense supernatural danger. It was deeply tied to the feathered serpent deity Kukulkan and directly linked to military conquest. Basically, Venus was something to be feared. They obsessively tracked it so their rulers could perfectly time their wars and royal sacrifices.
To manage all that danger, they mapped out Venus across a 584-day cycle. It kicks off as the morning star, which is this highly dangerous 263-day phase where its reappearance basically acted like a giant celestial war trumpet, signaling Maya kings to launch military raids. Then it hides behind the sun in what's called a superior conjunction for 50 days, before returning as the evening star. That phase was associated with sacrifice. Finally, it disappears again for a really brief, incredibly perilous 8-day inferior conjunction. Tracking these exact phases wasn't just math, it was quite literally a matter of survival.
All right, Part 3, the Dresden Codex. This was basically their ultimate science ledger.
So the Dresden Codex is this incredible folding screen book made of bark paper, and it's really the physical engine behind their mathematical genius. It contains the famous Venus tables tracking 65 full synodic cycles. And what's absolutely wild here is that it includes built-in correction mechanisms. Think of them like our modern leap years, designed specifically to stop errors from piling up over time. It's also got eclipse tables predicting cosmic danger windows and Mars tables forecasting warfare outcomes over a 780-day cycle. And the engine running all this, their base 20 mathematical system. Instead of counting in tens like we do, they counted in 20s. And, this is huge, they had a true working concept of zero. That was a massive mathematical leap that made these incredibly complex calculations possible.
The eclipse tables in the Codex are just fascinating. The Maya described an eclipse as the sun or moon being eaten by a celestial monster. Now, obviously, they didn't know the physics of orbital mechanics, and they couldn't predict exactly geographically where an eclipse would be visible.
But they empirically discovered what modern astronomers call the eclipse semester. By spotting these super tight mathematical patterns of 177-day and 148-day intervals, they could predict the exact danger windows when an eclipse might happen anywhere on Earth. Figuring out a global pattern like that with just the naked eye, it is mathematically staggering.
Actually, it's so staggering that modern scholars are still completely blown away by it. Astronomer Anthony Aveni put it perfectly. He said, "The Maya Venus tables represent one of the most extraordinary achievements in the history of science." This ancient work was just so far ahead of its time, producing calculations that European astronomers literally wouldn't match until the Copernican revolution, over 5 whole centuries later.
Let's move to part 4 and see how this builds in the real world. Buildings as fixed observatories.
Since they didn't have handheld precision metal instruments, the Maya came up with a totally different, honestly genius strategy. They just turned their entire buildings into fixed astronomical tools. Take El Caracol down in Chichén Itzá. They built this huge circular tower with window openings perfectly aligned to Venus's extreme northern and southern setting points. Or look at the governor's palace in Uxmal, where a central doorway creates a massive, multi-kilometer observation corridor just to track Venus. And all across the Maya lowlands, they constructed these Group E complexes. These were standardized plazas designed purely to track the equinoxes and solstices. By locking their sightlines into massive structures made of solid stone, they completely bypass the wobble and calibration errors you get with handheld tools. The building itself was the telescope.
Which brings us to our final section, part 5, the cosmic stakes, because astronomy here was pure politics.
So the crucial point is, why? Why dedicate centuries of backbreaking labor and massive architecture to this? Well, this was never just idle stargazing. For them, astronomy was a highly effective political weapon. For a Maya king, absolute astronomical accuracy was the ultimate proof of his divine authority and his royal legitimacy. If his royal astronomer successfully predicted a Venus event, boom, it proved the king was in direct communion with the cosmic order. But if they failed, that demonstrated a fatal weakness. If the math was wrong, the king's entire legitimacy basically crumbled.
What we're really looking at here is a profound integration of knowledge. The Maya didn't chop their world up into little compartments. They didn't separate science from religion or politics from mathematics. To them, it was all the exact same thing. By tracking the sky across multiple generations, they unified literally every aspect of their society into one massive, cohesive worldview. And honestly, that demands our absolute intellectual respect.
Which leaves us with this final, really provocative thought. The ancient Maya pulled off calculations that rivaled the greatest scientific minds in human history, using nothing but stone, positional math, and multi-generational patience. So, if they could track the heavens with that kind of astonishing precision, just by thinking in centuries, what could we possibly achieve today if we learned to plan on that same massive scale? Definitely something to think about. Thanks so much for joining me for this explainer, and I'll catch you next time. Keep looking up.